Hello, everyone, and welcome to our Go online meetup. My name is Gregory. I'm a software developer and a head of developer relations at Singula. We at Singula team do out stuff. We hire software developers, teach them, and contract them out to our clients in order to teach them the best possible way and to ensure that they offer code that I can be proud of. We organize different activities all over the world, including these meetups. And these meetups, they are special. They are a place to discuss things. We prepared for you three interesting talks, and the goal for these talks is not to educate someone on or to tell news. No, the goal for them is to discuss things. So we pre-recorded these talks, and right now I will start the first one. And after it concludes, the speaker and me, we will do a live Q&A session. So please prepare your questions. Right now, the talk, and after this talk, we will discuss things. And for our first talk, Timofey from Yandex will highlight the topic of test environments and fixtures.
Hello, my name is Timofey. Last few years I work at Yandex. My main language is Golang, and I also have experience in other languages, for example Python. In Python I like library PyTest, which provides fixtures for create a test environment. I tried to find fixture libraries in Golang and not found it. Then I make the library myself. Today I will tell about the fixtures in Go with library Fixtures. Today I will show a simple test in Golang without fixtures. Then I will show same tests in Python with Python fixtures. Then I will talk about features of fixtures and show same tests in Go with fixtures. Then I will show example of fixtures source. Let's start. Golang tests. It will be very simple tests. In first test we will create a directory. You can see the test source. It first part of source we prepare test environment. We create temp folder. Then we remove the temp folder with all contents. And test code. When we create a temporary directory within our work directory. If we will create a similar test with create file instead of a directory, we will repeat serialized code for create a working directory and remove it. Serialized code, useful test code. Common part of tests is create and remove temporary working directory. It will be fine if we will move out the code out of test code. We talked about simple Go test. Then I will show same tests in Python with fixtures. Our first test is create a directory. The test receives a folder as argument. Folder is a path for temporary dir. It is our work dir, and a test can use it from start of test. After test finished, the directory will be removed with all contents. If we need a similar test with create a file, it will be same. The test receive folder as argument. The test can use the folder, and after test finished, the work folder will be removed with all contents. Folder is fixture. The folder fixture will create a directory, allow to execute test, then remove directory with all contents. So, Fixtures provides a defined, reliable, and consistent context for tests. The one fixture can depend from other fixture. I will show it later. Easy cleanup. Every fixture can provide a cleanup code, and the tests don't need worry about cleanup. All cleanup will be made by fixture code. We talked about fixtures in Python, PyTest. Then we can talk about fixtures in Golang. I will show same tests in Golang with fixtures. Same test, create directory, and you can see service code, one line for create fixture environment, and one call to take temporary folder path. Function folder is fixture. When fixture called first time, it will create directory and return path to create a directory. Path will be returned only if directory created successfully. If something will wrong, fixture will fail test, and it allows to avoid boilerplate code for handle errors while we create our test environment. We can write more useful code and less service code. If we need a similar test with create a file, we can use same fixture. Let's compare test with traditional style and with fixtures. Traditional style with fixtures. You can see value of service code in both tests. Fixtures in Golang provide defined, reliable, and consistent context for the tests. Same as PyTest. One fixture can depend from other fixture. I will show it later. Easy cleanup. Folder fixture clean up itself. The test don't need write any code for cleanup. Test code only. For example, fixture will return same value during the test. For example, we can write test and call folder fixture few times. First time, second times, and so on. What we will see in log. before folder return first time, it will create a temp folder. Then first time, second time, and so on, it will return same folder. After test finished, Fixture will remove temp folder with all contents itself. We don't need any cleanup code in test. Fixture can depend one from other. For example, if we need some special folder, for example, inbox, in our working folder, and inbox need in many tests, we can create another fixture, inbox. Inbox fixture can call folder fixture. Folder fixture will create temporary folder. Then inbox receive good temporary folder, create path for inbox inside folder, and return it. The fixenv cage is a special function with fixture magic. It check about code of fixture will called only once. If inbox will called a second time, cache function detect it and return previous value. We don't need to worry about memories in fixture code. If fixture code will return non-nil error, cache function will fail test. Then we can try to use both of inbox and folder fixtures in same tests. As you can see, first, before work inbox folder fixture will create working folder. Then inbox create inbox directory. Then it will return, and we see logs from tests. And all of code of fixture inside inbox fixture or inside test will always return same value. After test finished, folder will remove temporary directory. As you can see, inbox fixture don't have cleanup code. It's okay because all cleanup will do by folder fixture. If we need cleanup code, then Fixenv library provides a simple path for it. Fixenv define cleanup function type. It's simple function without arguments and without result. Same as cleanup function in standard test library. And function cache with cleanup. The function like cache, and additionally it call cleanup code when test finished. Now you can see a source of folder fixture which was used in our test. It create a temporary directory and create cleanup function. It will called after test finished. If something will wrong, the fixture will return error and all tests will fail. Fixtures in Golang with Fixenv. Easy create test environment. In test code, you simple call fixture and get result value. You don't worry about creating environment. All will created in fixture code. Easy cleanup. Fixture can include cleanup code itself. In test, you only receive result value for work test. Then fixture will clean up itself. No need code in main test sources. Easy for reuse fixtures. Fixture is function. You can create own fixtures libraries and reuse it in few projects, or you can use standard fixtures from Fixenv library. And Fixenv has advanced features which wasn't shown today. It's use fixtures with params for create few similar instances of dependence, and reuse cache and reuse heavy dependencies between tests. For example, if you need database for tests and database creating is long, then you can define fixture scope, for example, test module, and all tests will reuse same database, and cleanup code will called after all tests finished. Today we talked about fixtures in Golang test. You can see more examples in Fixenv repository. You can use it in your project. If you like the video, give thumbs up to the video. It will help us to understand about you like their content and provide more content for you. And I will ready to answer your questions from issues in GitHub.
Hello, Timofey. Thank you for joining us.
Hello, Grigory.
That was a great talk about this project. And as a long-term Python developer, I really appreciate your hard work. And the first question that we will discuss is the main reasons for you personally and for the company you're working for to develop such a library. Of course, I understand that simple is better than complex, but complex is better than complicated. But still, creating such a library is a lot of efforts. So, what were the main reasons for you to start this project, to maintain it, to PR it right now? Please tell us.
Okay, it's a good question. Some time ago, I like to develop open source projects, and I like share my expertise for a lot of people, and I just like it. It's my personal project for fun.
Mm-hmm. Okay, and you were influenced by Python, PyTest, and fixture ideas. Am I correct?
Yes.
We have the first question from our audience. Let me move the screen so I can show chat here. So, have you implemented distributed tracing tools like Jaeger, Jaeger,
Yeah.
Jaeger? Jaeger. Yes, I still struggle to pronounce this tracing system. Yeah. So, do you have Jaeger support? And if so, where and how do you typically store the corresponding logs?
No, it isn't implemented now, and I have no plan for implement it. Because the Fixenv is a test library, not tracing library, and Fixenv will not used in a production environment, in test only.
Mm-hmm. Yeah. Uh,
Similar to PyTest.
mm-hmm. Let's discuss the projects we test. Do you use this library personally for some projects that you develop for yourself or as an employee of your company? What projects do you test using this library?
It's a good question, thanks. Uh, I use the library in my personal project, Let's Proxy. It is very easy proxy with issue TLS certificates on the fly, right during handle a request. Uh, the proxy can work at a personal server and it working at shared hosting with servers with many thousands websites. Uh,
Mm-hmm.
and uh, I use the library at my work. Uh, I maintain a few SDK for YDB. It is distributed SQL database by Yandex. And I use Python fixtures for Python SDK and use Fixenv for Go SDK.
Mm-hmm. Yeah, and since they are SDKs for the same database, I can think that tests are pretty similar. So it is easy for you to offer like similar body of tests. Great. What I want to talk next is an entry barrier for new developers. As seasoned developers ourselves, we know that for new developers, each unusual technology, which is not widely popular, adds some additional time to learn, to onboard for the project, and so on. Using fixtures as I can see them, it's a very uncommon technique for the Go developers. And I think for a new Go developer that will start, for example, to contribute to your Go library for this YDB project, they will discover your fixtures and like, oh, what's that? Oh, what's strange looking code? I need to read documentation. I need to learn something, and so on and so on. What do you think? Is it reasonable to bring such foreign ideas into Go language instead of using some popular solutions for fixtures?
Uh, in my projects, for example, YDB SDK, fixtures is not biggest problem. It is a very difficult project as SDK because it is have many features, and it's implement a few difficult protocols and some new idea uh, make test simpler and new developers uh, can more easy read code because developer see database, table, and new developer don't need research service code for with many lines for understand what the service code do, and he can understand. I take database, I take table, and I will work with the database and table.
Mm-hmm. Yeah, that's reasonable. And yeah, readability counts. I always ask for new solutions. Is it worth it to put additional burdens for developers to learn new approaches and new tools? Yeah, but as you explained, for some areas, it's perfectly worth it. But before developing this project, did you consider any existing libraries for Python, for Go test ecosystem? Did you evaluated any existing libraries and frameworks? Please tell me.
Yes, um, I research libraries to find existed solution for fixtures, and I don't found them. I used Testify for test helpers. I used some frameworks with test suite for grouping tests, but it is not same.
Mm-hmm. I have one more questions. You have demonstrated us that this library framework that you created, it already have an ability to do temporary directories. What other features does it have out of the box?
Mm. Out of the box, Fixen have a few standard fixtures. For example, give me free TCP port,
Mm-hmm.
give me a temporary folder,
Mm-hmm.
uh, give me a started HTTP server,
Mm-hmm. That's
um,
nice.
and I need to see something. Mm.
Please take your time, and I will take mine to drink some coffee.
Oh, provide me context for with lifetime as test.
Mm-hmm.
Go often take context and standard one of standard fixture provide context which will be expired when test finished.
Mm-hmm.
Mhm.
Nice. Timofey, thank you. I hope we will meet again on some international conferences since this work with YDB becoming pretty mainstream, and I saw it on Yatox conference in Serbia, and then upcoming international highlight conferences will test it for sure. So thank you. Please join us as a viewer for this stream, and I will bring us one more talk with one more interesting topic for which I am looking for your questions in our chat. Thank you, Timothy.
Thank you. Goodbye.
And our next topic will highlight Go error handling in 2023. Yeah, I do remember how Go error handling was 5, 6 years ago. All these red error. Of course, now we can fold them in modern IDEs and have other nice features, but it's still a hot topic to discuss. Please welcome Vitaliy from InDrive.
When an unexpected situation occurs in our programs, we want not only handle it, but also add information to logs. My name is Vitaliy and I am going to talk about it. When developers start working with Go, they learn that there are no exceptions unlike in other languages. There are errors instead of exception in Golang. And if we don't add any information to an error, it's not obvious where a problem is occurred. Firstly, we can add some clarifying message. After that, we can look up a message string in our code base and figure out where an error has appeared. In the end, we can find the clear message in our logs. The message stays clear while our application is simple. But in more complex services, we can get something like that. The big ball of text can appear when a service has more than 3 layers. Developers usually think about a part that they write at the moment. It's really difficult to think about a whole picture, a whole path of an error. In this situation on the screen, we must trace from the top to the bottom through all parts of our application, all parts of message, because the last message part is too common. Honestly, stack trace would look better here. But stack trace has a price. And that's why stack trace isn't added by default in errors. In other language runtimes, use stack unwinding traversing through function pointers in a stack, like it's shown in the picture. But not in Golang. Go's runtime uses an additional table with information about previous frames. We have to look up at this table for every frame. It's cost of stack trace price. There is a great repository by .doc where you can find more details. The link is in the QR codes on the screen. How expensive is the stack trace in Go? Let's see benchmarks provided by authors of one package for working with errors, RRX. The naive approach with FMTRF is getting stack trace by function from the runtime package. It's slower more than 1,000 times compared to FMTRF. But in absolute numbers, it's not a lot. It's only half of milliseconds. If we have nested DB call that equals 40 milliseconds or 200 milliseconds, this is the price that we are allowed to pay. Okay, we understood when an accident happens in production environment, we need a clearer error message and all context that is possible. How can we do that? The community creates many helper packages. For example, trace error for adding stack trace, or panic path that helps to find where panic was thrown. There are some problems with stack traces. Sometimes they are unreadable, and we must not forget to add stack trace in logs at the top level of our application. Adding a caller in an error also solves a problem with understanding where an error appeared. Getting a caller is incomparably cheaper than getting a full stack. A stack trace is not needed in common situation. Getting only a place where an error occurred in our service is a great trade-off. Return to benchmarks. ErrorX package adds a caller at every place where it's called. It's really fast, only 50 times slower than a simple error. This approach additionally allows us to make a beautiful trace formatter. But how can we add more information to an error? For example, in the payment processing domain, we want to see the user ID, country ID, payment ID, provider name that processes payment, and perhaps something more. If we will use errors for that, we have to return to FMT-RRF and the big ball of text, because our extra information is spread through applications layers. We can get the information about the user and country in the controller, about payment in the use case layer, and about payment provider in the bottom layers. We must not forget to wrap errors from bottom. And didn't forget about additional information. But we can spread additional information through a context. Almost every team where I have worked has written a package for this. This task is not trivial and has issues with duplicated keys, values changing, concurrency, etc. We can write something like this. In the end, we have to use a lot of additional packages or one really complex package. Let's remember, I told that error handling is more about adding logs and traces than about errors. Modern logger packages have a method that helps to add more information in the logger before writing a message. We can gracefully collect all data that needed and to throw logger through context. A part of community can notice that spreading additional information and logger through context is not a go way. It's not totally clear and seems a magic. And we all know context for cancellation. But I don't think that it's a problem. Logger's method for adding meta information give thread-safe guarantees. And helper functions can require a default logger for more obvious behavior. And it's really cheap solution that allow us separate logging and managing data flow using errors. To sum up, use standard FMT-RRF approach if your project is not big or for single package. Adding stack trace has a price and is not enough. Additional information collecting in every layer is not easy. Use loggers where an error has appeared to have the whole picture in your logs and traces. Thank you for attention.
Vitaliy, welcome from the past to our real-time stream, and thank you for your talk. Yeah, error handling is one of my favorite topics. I remember 20 years ago, then I was one of the developers behind the Redmin project, and it was a system utility for remote controlling computers, and it should have been very, very stable to never crash, to allow people to connect to some remote computers behind the North Pole and so on. And we did have a very big, complex error control system, error recovery system, and yeah, we have spent years creating it. And now I can see that with the Go programming language, this simple basement with red and R, it slowly starting to assemble a number of open source projects to help developers with better error control. As a Go developer, what do you think are the main important points for Go developers to handle with errors? Like, let me elaborate on this topic. If you join a new project and you want to evaluate, do we have a good error control or not? What will you look for? How will you evaluate it?
First, I start with understanding where our team handle error in the top level or in the place where error appeared. And if we handle error in the top level, we should understand where error appeared in our code. And we have different approach, and I try to figure out what approach my new team choose. And if our team handle error in the place, I try to figure out what additional data they try logging.
I can see that the Go programming language error handling uses lots of words, statements, like 4 lines of code for each block, minimum, sometimes more. And I see that modern IDEs, they provide developers with an ability to fault all error control within one line, like with some virtual elements that designates that somewhere inside error control is happening. What do you personally think about this approach? Should we hide all this excessive information from developers' point of view, or should we work with plain text and give our brains some time to get used to this Go approach, so we can filter it with our brain, not with IDs?
I think that error handling it's a big part of our code, and we shouldn't hide some implementation of handling error. I tried hide error. I tried to use plugins that change brightness of error block, and my code become more difficult for reading after that, and I turn it off.
Mm-hmm. So we have a question from our guests. With the proper error control, you need to establish a good code review practices within your team. What are your code review practices? How do you review other people code, especially if they are dealing with errors? How do you evaluate their code?
I think I try review 2 point. One point is what additional data my colleagues add to error or to logs, and miss they something or not. And second point, where they handle error, and can they collect all necessary information in this place or not?
Thank you. The Go programming language is more than 10 years old. And as you can see, there is no popular ubiquitous library or framework to help developers with error control and logging. I am curious, what is your personal opinion? Why no library or framework didn't win our hearts yet? Why there is no clear winner yet?
I think that the main cause that the big project with writing in Golang was especially infrastructure project, Kubernetes, database system, and so on. And in this system, we can simplify errors. They able to do that. Problems with errors appeared in the application with multi-domain logic, with a lot of business logic, and Golang became popular in this field, banking system, and so on. I guess few years ago.
Our previous talk was about Go test suites and fixtures, so I cannot withhold myself from asking the next question. Do you think it is important to completely cover your code with tests, including error handling, like 100% code coverage, or not? What is your personal approach to test your code in respect to error handling?
Mhm. It's really difficult question, and it depends on project and code base. I try make a lot of end-to-end or integration tests in our applications. Because we have not a lot of logic that we can cover with unit tests. If we use end-to-end test, we don't think about error handling. We think about what our API give to us. But if I write a unit test, sure, I try to test all cases and error handling also.
While writing our code, sometimes we, software developers, hesitate. Should we add some proper error handling with meaningful messages, or some things should not happen and we should just panic if it happens and test it ourselves later? And we developers, we try to preserve some balance between putting too many error control code in our code base, or writing to a few error handling, and that results in strange panics in runtime that we can't debug. Do you have any rule of thumb, any routine that you follow to ensure that that the amount of error handling code that you add to your project is just right, not too small and not too big? How do you answer the questions? Did I wrote the reasonable amount of error handling code?
I think it not depends only of my opinion. Every team should choose strategy for messaging and so on. And after incidents, we discuss usually that what we can do better, what information we can add to our errors, our logs, for react to accident more quickly.
By the way, during your talk and now, you often mention logging and adding additional information. How do you think error control is connected with logging? Should we always have a logging facility connected to our application and our error control to be written so it interacts with some logging facility? Or for simple projects, it's possible just to write something into stdout and don't bother?
I guess that for simple project we can escape logging and return error to stdout or to response body. For small project it's okay, but medium and large project we should have great logging.
Thank you, Vitaliy. It was a pleasure. Please stay with us for our third and final talk, and thank you again.
Thank you.
And our final talk from Denis is focused on NoSQL databases and system design cheat sheet. Please, Denis from Plata.
Hello, my name is Denis, and today I wanna talk about NoSQL databases, system design cheat sheet. So, a few things about me. My name is Denis Larionov. I'm ex-senior software developer at Lamoda. I'm coding at Go and used to code at PHP. I have more than 7 years of experience in software development, and let's begin. So first of all, I want to speak about key value DB as an example of NoSQL database. In key value DB, data is stored as key value pairs. And the key is unique and is used to access the corresponding value. Such databases provide fast data access by key, and it's a main feature of such databases. As for examples, I can provide Redis and React. For use cases of such databases, it can be used for caching, so you can put some frequently loaded information in front of your database or web server to get it quickly. Also, it can be used for session management, so you can store session information about your user in such databases. And also like login and some user preferences. Also, it is good for counters and statistics, so you can store like retweets, likes, and some like rate limiter counters and etc. In such stores. Also, it is good for geodata and geolocation. So you can store location information such as geolocation coordinates and point of interests on map. Also, it can be considered as configuration storage. So you can store and update application and system settings. Also, I want to speak about document DB. So in such databases, data is stored in document formats such as JSON or XML. It provides flexible data schema, and it allows for storing and retrieving complex documents. It really excels where data can be semi-structured or its schema may change over time. For examples of such system can be MongoDB or CouchDB. And let's speak about use cases of such databases. It can be used for content management, so it can efficiently store and manage content such as articles, images, video, and audio. And it's also pretty useful in like digital libraries and in content management systems like CMS. Also, it's widely used in analytics and reporting. So you can store diverse data and store generated data in it. So let's say you can store pre-generated report for your user in such databases. Also, it is good for user management and authentication. It simplifies user management. You can store roles and authentication in it. Also, it's widely used in gaming industry because you can store game objects, character settings, and player achievements in it. Accounting and task management systems are also good for storing in such databases because you can store like managing of tasks, projects, and you can store to-do lists in such systems. And documents can represent tasks as their related attributes. Also, it's used in Internet of Things, so you can store data from sensors and Internet of Things devices, and as they can store various types of data and so on. Applications with evolving schema really need such databases because you can store it as a document. You didn't need a particular schema to store the data, and it's really good when you have such application to choose this type of database. So let's talk about Columnar DB. So what is it? In Columnar DB, data store in columns rather than rows. It allowing for efficient processing of large volumes of data and analytical queries. It has high read and write performance. It has also high scalability out of the box. Also, I should notice that it has data compression technique, which helps you to store more data with less memory assumption. As for examples for such databases can be Vertica or ClickHouse. So for use cases of such database it's really good for analytics and big data warehouses because like it has really high performance for read and write, and it's really useful for big data warehouses and analytical systems. And also it helps to process a big amount of data, which is also very helpful for such systems. Also, I can suggest using such databases in financial systems and trading. So you can store transactions, operation systems, operational history, and like quotes in such systems. It's also used for monitoring and audit systems. So the ability to store and analyze event and audit log data makes them useful in like security and monitoring systems. Also, it can be used for time series accounting systems and all time series related data. Also, it's good for real-time systems because, as I said, it has high read and write performance, and it is really good for processing transactions and like event processing of your system. Also, it is good for version control and archiving sized systems. So you can store different versions of your document in such a database and track different versions of this document, and also retrieve particular version of document when you need it. Also, I want to speak about white column DB. So white column stores use as data model based on column families. It provides a high degree of schema flexibility. So column families and columns themselves can be dynamically added without changing the entire schema. And it also scalable out of the box. It's really, I need to mention that it has the same use cases as columnar.db. So that's why many people confuse columnar database with white column DB. So they have some similarities, but they have significant difference. And you should ask, what's the difference? The difference is in a way of these databases store the data. As for columnar.db, it stores each column separately on disk. So each column has its own file. As for white column.db, it uses a data model based on column families. So what is column family? As you can see in a picture, it's like example of column family. You can see row key. I think we can say we can speak about row key as about partition key. So it's all primary key in relational DB, for example. So for each row key, we have columns, and each column has its value. So column 1, it's like the name of our column. Column 2 is also the name, and each of these columns has its values, and all of it combining in column family. Also, each family can contain different columns, and data rows can contain different families. So, as you can see in the picture, we have personal info column family for one person, like with, let's say, with row key user 1, and we have like name and surname for him. And also we have different column family for address for the same user, and it has the same row key but different columns. It's address and his phone, and it's different column families which we can store on different parts of our disk or even on different nodes of our system. As for example, for such systems can stand Cassandra and ScyllaDB. So let's dive into GraphDB. Graph databases are designed to store and process data organized in graph structure. They model data as a graph, and where nodes represent objects and edges represent relationships between them. As for examples for such system can stand Neo4j and Amazon Naption. Use cases for such systems is social networks. It's really good for social networks. You can like storing connections of friends in social networks and other connections that you need. Also, it is good for recommendation systems because analyzing user preferences and relationships allows for personalized recommendations, including products, music, and movies, and it really improves personalization of different products. Also, it's good for geospatial data. So graph databases well suited for storing and analyzing geospatial data. It can be like maps, especially roads, and some locations. It is widely used in bioinformatics and genomics. So it can be used for analyzing genetic data, gene and protein relationships, as well as metabolic pathways. It is also used in fraud and security to analyze networks and connections and prevent fraud and enhance security of systems and applications. Also, it's used in network and transportation system analysis. So you can optimize relationships between you can optimize transportation roads and telecommunication systems network. Also, it's used in relationship management systems and network analysis. So it can be used both in sociological contexts, in relationships, analyzing relationships between some entities, and so on. Okay, let's speak about time series DB. So for time series DB, I can say that it's specialized on storing and analyzing time-based data. It provides efficient storage and fast access to ordered data. Also, it provides ability to store and analyze data over time. And it's really important for a variety of fields where tracking, analyzing, and forecasting data changes are required. So, as for examples, we can consider InfluxDB and timescale DB. So, what is use cases for such databases? I can say this is collecting and analyzing data from multiple sensors and devices in real time. Also, it can be monitoring the performance of computer systems, servers, network, and applications. And also it's event and action tracking for security and monitoring purposes. And I can add it is good to record events and audits, as well as to ensure data integrity. So, as for conclusion, each type of NoSQL database is designed for different user scenarios and has its unique characteristics. The choice of a specific database depends on requirements of your project and the characteristics of your data, so you should choose it wisely. I should say that flexibility and scalability of NoSQL databases allow for efficient handling and of large volumes of data and modeling complex relationships. On the other hand, relational DB provides solid guarantees of data integrity and reliability. Also, it's important to know that relational DB provides ACID transactions, which NoSQL didn't provide. So, choosing between relational and NoSQL databases, you should consider requirements of your project, data volume, complexity of relationships, and usage scenarios. That's all. Thank you very much. I really appreciate that you're here today. Thank you. And here's my LinkedIn profile and slides. You can contact me. So have a nice day.
Oh, Denis just informed me that he will not be able to join us for the live part of the discussion. That hurts me a lot because as an organizer of meetups, conferences, and other activities for software developers, I do them exclusively as places for us programmers to come together and to discuss things. I hope today's two discussions were interesting and for Denis to join us at some other activities, our own activity, or from our friends and industry colleagues. Thank you for being with us. My name is Gregory. I am a software development and developer relations at Singula team, and see you later on other events. Bye bye.